Okay, here's a quick review of integration. Remember, integration is reversing derivatives, and there always must be this dx. So if I take the derivative, I bring the power in front and reduce the power by 1. So to reverse it, I will raise the power by 1 instead of multiplying by this power. So when I'm doing the derivative, I bring the 6 in front and multiply by it. So I must divide by 6. And when we take an integral, there's always a constant of integration. Why? Because if I take the derivative of this, let's do a derivative. I've got x to the 6th over 6, so I bring the 6 in front, reduce the power by 1. Derivative of the constant is 0. The 6's cancel out. So key is raise the power by 1, divide by the new power. Remember when I have square roots, I should change them to fractional exponents and negative exponents. So now I raise the power by 1, adding 1 to negative 1/2 is 1/2, and I divide by the new power 1/2. Dividing by 1/2 is the same as multiplying by 2, and I get 2 square root of x plus c. I should convert back. Remember the derivative of e to the x is e to the x, but here I don't have just an x, so the chain rule would say I multiply by the derivative of that inside. So if the derivative of e to the x is e to the x, the integral of e to the x is e to the x. The chain rule would say I multiply by the derivative of this exponent, which is negative 3. To reverse the chain rule, I'd have to divide. Same thing here. So the derivative of sine is cosine, so the integral of cosine is sine. Chain rule would say I multiply by 1/2, so I have to divide by 1/2, which means 2 sine x over 2 plus c. This last one here has multiple terms. Well, we just integrate them term by term. X squared becomes x to the 3rd over 3. Oops, let's make better 3 there. Negative 2x becomes negative 2x squared over 2 plus 5x plus c. The 2x over 2 should be simplified to, or you'll often see it written like this, with a 1/3 instead of an x cubed over 3. Either of the last two answers are fine. The unsimplified one is not. And that's basic integration. We also did integration by substitution or U substitution. And this one is kind of like some of the last ones there. Our U is 4x minus 1. Our du is 4 dx, which I can divide both sides by 4 and have 1/4 du equal to my dx. So now I substitute. 4x minus 1 becomes a u, dx becomes a 1/4 du, which I will bring to the front. I can bring constants to the front of the integral. I now raise my power by 1. 1 plus 1/2 is 3/2. Divide by 3/2, which is the same as multiplying by 2/3. 2 times 3 is 6. U, I must substitute back for U. I'm not allowed to leave it as U. The problem was not given in terms of U, so you're not allowed to leave it in terms of U. Oops, so it's 4x minus 1. It's important to get the details right. Easy to get them wrong. Our next problem is 1 over cosine squared 2x dx. Now you can't really use U substitution. But this one is a nice trig identity. 1 over cosine is secant. So 1 over cosine squared 2x is secant squared 2x. And we can remember that the secant squared of U is the derivative of tangent, so the integral of secant squared is tangent. We'll reverse the chain rule by dividing by 2. We'll see. You could do a U substitution on that, but you don't really need to. Couple of more U substitution ones. This one is one of my favorites. So again, I don't see anything here. But I know that tangent of x is sine x over cosine x. And these are derivatives of each other. So I'm going to pick U to be my denominator. Cosine x. Du, the derivative of cosine x is negative sine x. So negative du sine x dx is right here. This is all multiplied, so it's all on top, so it all goes together. When I substitute, I get negative du over u, or negative 1 over u du. Same thing. Those are equivalent. What has a derivative of 1 over x? The ln. Negative ln u, well, c. U was cosine of x. There's technically an absolute value there. I should put it in this case because cosine is not always positive. Now I'm going to show you how you get to what they give as the answer. So they give the answer as this. So the laws of logs say ln over y. Well, the ln of 1 is 0. That's a 1. So this equals ln. The 1 can go into the absolute value because it is a positive number. I don't need to absolute value anything there. You need the absolute value because you can't take the ln of a negative number. And 1 over cosine is secant. Oh, it doesn't have a dx at the end. It has a plus c. I don't know why I wrote a dx. And that is the integral of tangent of x. The ln of the absolute value of the secant of x plus c. When you do definite integrals, And you look at this and you go, which one is my u? Well, the derivative of tangent is secant squared. The derivative of secant is secant tangent. Actually, there's two ways you could do this, but the easy one is probably using tangent. No, not dx, just tangent of x. Du is then taking the derivative of the tangent of x, which is secant squared x dx. I also need to then do u of pi over 4. The tangent of pi over 4 is 1. Its opposite over adjacent pi over 4 is 45. So that's a 45, 45, 90 right triangle, where these are both equivalent, whatever they are. Opposite over adjacent, 1 over 1. U of 0, the tangent of 0 has an opposite of 0 and an adjacent of 1, or something like that. So now I'm going to substitute u du. Very easy one. I'm going to change my bounds to be in terms of u. So my upper bound, instead of being pi over 4, is what I got when I did u of pi over 4. My lower bound is still 0. They happen to be the same. It won't always be the same. So u squared over 2 plus c. I raise my power by 1. To do this, to plug them in, no, I don't need a plus c. This is a definite integral. To plug them in, I can now, you don't have to change your bounds. You can switch the u back to tangent of x, but you could also just plug them in. It's always upper minus lower bound. That's 1/2. There is your review of integration.